Okay, we're back. It's 6-2 this time. Hopefully it's not 26 minutes long. Let's get into it. So what we're going to look at is 6-2 inference for slope in regression. And what this really means is a 4-step process. Yes, that's right, folks. We're back to this. So this section is actually fairly easy once you understand the basic idea behind linear regression. What we're going to do, I'm going to show you in Excel how to create something similar to this. It's not quite as nicely laid out as well as this. I don't know if the histogram shows up. I don't remember. But for sure, you've already seen how to do the scatter plot. Once we have this information especially, we can finish out the 4-step process. Sorry, I was pointing at that, and I also meant this. In fact, this is even more important, and this is what it's going to look like. So we've got these 3 things, 1, 2, and 3, and we're going to go ahead and get into Excel to show how that works. All right, so we have the data from yesterday. Let's bring this up. Pay special close attention to what I'm about to do. All right, so we grab all this data. You're going to go to the data tab up here, right? Data, data analysis. You guys have done this before, hopefully. And then down here, you'll see one called regression. Click on that, click OK, and it pops up with this form. Now, this is where things get really tricky. If you do not follow these steps, you're going to get different answers, and then you're going to be like, why, Abraham? Why is it like this? And I'll say, hey, did you get the labels? And you'll say, what are you talking about? Pay attention. All right, when I click this button, I'm trying to get the data. All right, so let's see. This is the Y range. So we're going to grab the Y, and the Y is the mortality index, right? So grab everything, including the label. I can't say that enough. Including the label. Do the same for X, including the label. And then down here, make sure you check the labels box. All right? Confidence level. If the problem asks you to come up with a particular number for alpha, then you will change this. But remember, if we don't tell you, then the alpha is 5%. So alpha is going to be 100 minus that 5% to give you this confidence level of 95%. So we're going to use 95% here. All right, so for an alpha of 5%, use a confidence level of 95%. All right. Then what you want to do is come down here. Make sure you click another very important point. New worksheet ply. All right. Don't choose output range. For some reason, things get wonky. Choose a new worksheet ply. It's going to create a new tab. Okay. Then click on, just go ahead and click on all these. Why not? Let's take a look and see what they all do. And then the normal probability plots, right? We're going to see what all this stuff does. Okay. If, and I want to say this again, if you needed to have a different confidence level, then you could change it this way. So let's say we wanted a alpha of 1%, then you would change this to 99. We don't have that. We have 95%. We're going to say that alpha is 5%. Okay. All right. Send me a question if that didn't quite make sense. All right. Regression. We click OK now. Boop, 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 boop. It's doing this calculating, and there's a problem with the clipboard, but you can still. Okay. I don't know why it showed me that error, but we're going to push past it. All right. So I'm going to open these up a little bit more. All right. So we have a lot of information here. Okay. And if you'll notice, if we go back to the workbook real quick, let me show that really quick. Let's see, page 232, you see the summary output regression statistics. That is right here in Excel. Okay. The residual plot, I don't think I got that one in. Well, Oh, there it is, residual plot. So we have a graph here in Excel that is the residual plot, and it looks fairly similar to that, the one in your workbook. Okay, the other one in your workbook, the third circle or oval I made is showing this section right here, right? Cool. And you'll see the numbers are roughly the same. I guess they rounded in our workbook more than they did here. Awesome. All right, so let's get into this problem now. Back to your workbooks here. It says, number 1, does evidence suggest that mortality rate is related to mean annual temperature? Conduct an appropriate test. This is the 4-step process. We're about to get into it, all right? So state the hypothesis. So the way that you want to state the hypothesis, it's pretty similar to what we did in the past, except some things are they're going to look slightly different. We want to have a null hypothesis such that b sub 1 is equal to 0. And then you want to have an alternative hypothesis such that b sub 1 is not equal to 0. So remember, I always said for null hypothesis we want those equal. And then we had 3 choices for this. And under this problem we're going to have does not equal. Okay. All right, what does that mean? Well, let's look back at our formula. Y hat equals b sub 1 x plus b sub 0. So b sub 1 is a slope. And remember, if we had a graph, right, if the slope was positive or greater than 0, then this b sub 1 would be, for this one, this beta sub 1 would be greater than 0. But if we had something that was horizontal or constant, we'd have a b sub 1 equals 0. If we had one that was negative, then b sub 1 would be less than 0, right? So what we're looking for our null hypothesis is that y is not affected by x, and that happens if b sub 1 is equal to 0. In other words, there's no slope or no change in y with respect to x, right? And the alternative hypothesis is clearly that this has a change, whether it's positive or negative, we're not sure yet. We're just saying that that x is going to change y in some way. All right, so that's your hypothesis for this problem. Step 2, conditions line. They give it to us here. You'll have to actually come up with these. We're not gonna give you all these this part of it. You'll have to write all that in, and this part of it, and so forth. But let's talk through that. So the conditions, linear. The pattern in the scatter plot, right? Because that's what we've been looking at, is linear, right? We already talked about that before. Independent. Well, we are given or we assume a random sample. Well, I don't remember what the whole problem set said, but I think it didn't tell us, so we're going to assume. In normal residuals. So this is talking about that histogram. We didn't draw the histogram, but if you were to draw the histogram, you would say the histogram appears, let's say roughly, oh yeah, we have the histogram here, sorry. It's not really normal either, is it? It's just sort of like, yeah, let's go with roughly even. Okay, it's not quite, but it's roughly, and that's really bad. But who, at this point, we're just trying to get this stuff done. Again, that's that subjective stuff. I'm not going to hold you to it too much. If you don't like it, you can always say, I'm assuming it's roughly normal. All right, if that makes you feel better because and it kind of makes me feel better because this doesn't look normal, does it? So we're going to go with that for now. All right, E, equal variance. The residual plot, which we did show, the residual plot shows, and this is the residual plot, it's basically showing you that the numbers or the dots on above that line are roughly equivalent as far as density to the ones on the bottom, right? So something that wouldn't be roughly dense, maybe something that had like this. You can definitely see there's more going on top than there is on bottom, right? But in this case, they're roughly the same on both sides as far as being distributed there. So that's what they're talking about in this residual plot, that it shows it's also roughly even from left to right. Cool. So this is no different, right? We have hypothesis in step 1. We have conditions in step 2, and then step 3 we can start doing some t-test statistics value. Well, this is the cool part about this section, is there really isn't much to calculating the t-test statistics, because if you look in Excel, it was given to us. Let me show that graph. I'm going to highlight this, and let's go with light green. You'll notice there's different aspects of this, right? There's this intercept, and then there's a mean annual temperature. We only, for this part, care about the mean annual temperature, so we're going to highlight that in yellow so that you can see what I'm talking about there. And if we go back to this t-statistic, you see that here it is. Let's put that in orange. Okay, so our t-statistic is 6.7578. Let's go with that. So t-test is 6.7578. And nicely enough, they've given us right next to it the p-value. So that p-value in this case is 9.20184, and that e is times 10 to the negative 6. And if you remember arithmetic, that means it's 0.12345620184, right? So there's basically, it moved over 6 places, right? That's what the negative 6 means. We moved to the left 6 places. All right. Cool. So that is the p-value, that number there. Awesome. All right. Cool. So we did step 3. Step 4. Now we have to state the conclusion, right? So if since alpha is 0.05, we reject the null hypothesis, right? And this is because 0.00009200184 is less than 0.5. All right. And then, of course, like every other one, you're going to state a sentence. And in the workbook solutions, you can probably just read this. But there is significant evidence to suggest that mortality rate and mean temp are linearly related. All right. Cool. So we did all 4 steps, and that's really, honestly, that's really what you're going to do on an exam. If you have a problem that is a linear equation, then that's what you're going to do on the test. So that's all there is to this section. That's 6.2. Now you can, of course, practice on part 2 and then look at the solutions. I'd spend time doing the rest of these problems, but that's it. I don't have any more to tell you about this one. We're done. All right, hey, thanks for watching again. This was 6.2, and we are done. See you in the next one.
My dad's office, my dad's desk, dad's phone, ding ding. My dad.
Yo, well.
Man, I love this.
Yeah, Michael, this is where all the magic happens.
Okay, let's get started. Question number 1. What's your job?
I'm a senior executive statistical analysis technician.
You're a senior executive what?
Well, in plain English, I concatenate diverse statistical information to maximize the potential utilization of data.
So, you give people data?
You know, a lot of people think that. No. My job's not about output, it's about throughput.
So, you throughput data?
Well, now you've lost me, son. Oh, listen, Michael, you know the 8 tracks you love so much?
You make them?
No. But because of us, other people who make them are able to make them better.
So you fix stuff?
You could say that, but I wouldn't. Right. This is the performance index before my involvement, and this is after.
Okay. So you're responsible for this?
You can't credit me with that. That's probably a statistical anomaly.
But you made the chart, right?
I wish.
So do I. Hey. Do you have customers?
No, they're more like clients.
But you have clients.
Sort of.
And you provide them a product?
It's more like a service.
A service?
Well, not...
To maximize the potential utilization of the data.
If we did that, we'd go out of business. And then we look at the chi-squared here, apply the standard deviation here, and correlate the results with the actualization median here. And that's what I do. And I can't make it any clearer than that.
I'm just gonna say you're a farmer.